Good day, everyone. I'm Ivan Claire Mendoza from BS ECE 3B, and now I will perform my performance number 4 in ECE 23, Adaptive Data Modulation. What is adaptive data modulation? This modulation is a refined form of data modulation. This method was introduced to solve the granular noise and slope overload error caused during data modulation. This modulation method is similar to data modulation except that the step size is variable according to the input signal in adaptive data modulation, whereas it is a fixed value in data modulation. We have here the block diagram. The transmitter circuit consists of a summer, quantizer, delay circuit, and a logic circuit for step size control. The baseband signal is given as the input to the circuit. The feedback circuit is present in the transmitter is an integrator. The integrator generates a staircase approximation of a previous sample. At the summer circuit, the difference between the present sample and the staircase approximation of previous sample is calculated. This error signal is passed through the quantizer, where a quantized value is generated. The step size control block controls the step size of the next approximation based on the either quantized value is high or low. The quantized signal is given as output. At the receiver end, the modulation takes place. The receiver has two parts. The first part is a step size control. Here, received signal is passed through a logic step size control block, where the step size is produced from each incoming bit. Step size is decided based on present and previous output. In the part of the receiver, the accumulator circuit recreates the staircase signal. This waveform is then applied to low-pass filter, which smoothens the waveform and recreates the original signal. The adaptive data modulation theory. In adaptive data modulation, the step size of staircase signal is not fixed and changes depending upon the input signal. Here, first, the difference between the present value and the previous value approximation is calculated. This error is quantized if present sample is smaller than the previous approximation. Quantized value is high or else it is low. The output of one bit quantizer is given to the logic step size control circuit where the step size is decided. At the logic step size control circuit, the output is decided based on the quantizer output. If the output is high, then the size is doubled for the next sample. If the quantizer output is low, the step size is reduced by one step for the next sample. So we have here the applications of adaptive data modulation. This modulation is used for a system which requires improved wireless voice quality as speed as transfer of bits. In television signal transmission, this modulation process is used. The modulation method is used in voice coding. This modulation is used as a standard by NASA for the communications between mission control and spacecraft. Motorola's SecureNet line of digital radio products uses 12 kbps adaptive data modulation. To provide voice detection quality audio at deployed areas, military uses 16 to 32 kbps modulation system in TriTac digital telephones. U.S. Army forces use 16 kbps rates to conserve bandwidth over tactical links. For improved quality, U.S. Air Force uses 32 kbps rates. In Bluetooth services to encode voice signals, this modulation is used in 32 bits per second rates. HC55516 decoder is used in various arcade games such as Sign Star and Smash TV, and pinball machines such as Gorgor or Space Shuttle to play pre-recorded sounds. Adaptive data modulation is also known as continuously variable slope data modulation. This modulation encodes at 1 bit per sample. Here, the encoder maintains a reference sample and a step size. Before deciding the step size of the input signal, it is compared with the reference sample. This modulation method compromises between simplicity, low bit rate, and quality. So as a summary, we have the advantages of adaptive data modulation. Adaptive data modulation decreases slope error present in data modulation. During the modulation, it is used as low-pass filter which removes the quantized noise. The slope overload error and granular error present in data modulation are solved using this modulation. Because of this, the signal-to-noise ratio of modulation is better than data modulation. In the presence of bit errors, this modulation provides robust performance. This reduces the need for error detection and correction circuits in radio design. The dynamic range of adaptive data modulation is large as the variable step size covers range of values. So, that would be all. Thank you and keep safe.